Okay. Our second chapter will be mostly polynomial equations, polynomial functions. But we're going to start with the probably second most basic polynomial, and that's a quadratic. Okay. First most basic is a line. We're not going to worry about lines right now. I know you guys know how to do lines. Okay. But we're going to talk about quadratics. Everything that I talk about today should be something that you have learned in Algebra 2 or Algebra 1. Okay? So there are a couple of skills that we need to brush up on. Okay? So first of all, what is a quadratic function? How do we know an equation is quadratic? The highest exponent is 2. Very good. Okay? Ax squared plus bx plus c. That gives you a quadratic equation, right? If we were to graph a quadratic equation, what is it going to look like graphically? What is that? A parabola. The parabola is going to open up, or the parabola is going to open down. Okay. Now, you did an entire chapter in Algebra 2 on quadratics. Remember that chapter? Okay. When you did that quadratics chapter, you had something called vertex form. That is going to be what we call standard form. Okay? You can still call it vertex form. I will not take that away from you. But for some reason, our book calls it standard form. Okay? A times the quantity x minus h squared plus k. Why would this be called vertex form for you last year?
Because the opposite of h and because the h and the k is the vertex.
All right, hk actually gives us the vertex. If we can get it into standard form, we know where the vertex is going to be. What else is nice about what we now call standard form is it looks like the parent function of x squared that's been transformed. Do you agree? Write h up k. A is going to give you a vertical stretch or shrink. Okay? We just got done with all of our parent functions and transformations. So if we can write this in standard form, it is going to be very quick for us to graph. Okay? Now, our vertex is HK. What is this red line I have graphed that goes through the vertex? Do you remember what that is called? Symmetry. It's the axis of symmetry. Okay? The vertical line that splits the parabola in half and goes through the vertex, that is called the axis of symmetry. Okay? It is a line, and so I do expect you to write it as a line. You're going to have to give me a timeout. I'm going to have to do this again, guys. I apologize. There we go. Okay, so like I said, if we can write our quadratic in standard form, we can easily figure out what the graph is going to look like. You don't need to write this down, so you're talking about standard form, okay? If A is positive, with your hands, show me what our parabola is going to look like. Oh, there's so much confusion. Okay, all right, like this, with your hands. What about if A is negative? It's going to be upside down, okay? A is positive, it opens up. A is negative, it opens down, okay? This is going to tell us our shifts, okay, which is giving us our vertex. And then if A is something other than 1 or negative 1, we know we can make that stretch or shrink. Now, what we need to figure out is how to get a quadratic into standard form. Okay, that is the skill we need to work on today. So go ahead and write down this equation. If we get a quadratic that is not in standard form, we can perform a task called completing the square. Do those words sound familiar? Do you remember how to do it? Yes? Okay. All right. As we go through completing the square, I'm sure it will become more familiar, but if you don't remember it, like right this second, it is going to be okay. So I'm reteaching it. So, first of all, you can only complete the square if the leading coefficient is a positive 1. In this example, the leading coefficient is a positive 1. We will look at what happens if it is not. Okay? What we are going to do is we are going to add a mystery number to form a perfect square trinomial. Okay? I'm going to come off to the side here just to give you a little bit of an example. X squared plus 10x plus 25. What does that factor to? X plus 5 times x plus 5. X squared plus 10x plus 25 is called a perfect square trinomial because we can factor it into something squared, this binomial squared, okay? So we basically want a mystery number to force that to happen, okay? But can we just like add something to an equation? No, that's changing the value, okay? So how do we balance things out in algebra? There are two different things we can do. What did you say? Subtract it on the same side. Or what's the second option? Add it to both sides. Okay? Now, since we are not solving an equation, we're rewriting basically an expression. We're going to go with what Eli said, and we are going to add and subtract the number to the same side. Okay? So we still have x squared minus 6x minus 1, but we're going to add and subtract the same number. All right? Now, there is a method for figuring out what this mystery number is. Remember what it is?
Just half it, b squared.
Okay. First, you are going to take b over 2. This right here is b. All right? So what is b over 2? Okay, so negative 2 squared, hold on. Oh, Mrs. Holman, I'm sorry. I was getting ahead of myself. I knew the answer was 3, and so I wrote 3. There we go. B over 2 is negative 3. So b squared goes right here. Okay. So what we have is x squared minus 6x plus 9 minus 1 minus 9. We are not changing the value of our equation. Okay. So now, what does x squared minus 6x plus 9 factor to? X minus 3 times x minus 3. Okay? It should always happen that it factors to a binomial square. That is the purpose of completing the square. And then left over we have minus 1 minus 9. there is our quadratic written now in standard form. Okay, first of all, are there any questions about the completing the square process up here? Questions about the completing the square? Okay, so let's talk about this now. Once we have it into standard form, we can easily identify the vertex. Okay, Lindsay A, where's our vertex?
-3, -10.
Lindsay, I want you to look back at the standard form with the A and the H and the K. And inside the parentheses of squared, what does it say?
X minus H.
X minus H, right? And this says X minus 3.
Oh, so I just do the positive.
Okay, good. Okay, since our standard form has X minus H, if it's subtraction, we're going to keep it as a positive number. If it's addition, that's when we'll have a negative. Okay? Our axis of symmetry. That is something else I'll expect you to be able to tell just from the equation. It is a vertical line that goes through the vertex. So what would it be, Marissa?
3.
Like that? 3 is correct, but I need it to be the equation of the line. So how would we, what else do we need with it for it to be the equation of a line? What? 0, 3 would be a coordinate. Here, let's graph it so I can explain to you what I'm talking about, okay? So, using our transformations, we know we need to go right 3 and down 10. Okay? So, this line right here is our axis of symmetry. 3 is the number that we need. Since it's a vertical line, we need to write x equals 3. Okay? And I'm actually glad that you did that because on like a quiz or a test, if you just give me 3, I will not give you full credit for that. It does need to be the line. Okay, so x equals 3. Okay. All right. Should we do another example? Need to practice this completing the square. All right. What's different about this equation? The leading coefficient is not 1. Okay? That doesn't mean we can't do it at all. All right, that just means we have to do something to it before we can complete the square. Okay? So if your leading coefficient is not 1, what I would like you to do is factor out that leading coefficient. But since we know we need the plus k at the very end, to avoid fractions or complicated numbers, you really only need to factor out that leading coefficient from the x terms, and we can leave the plus 7 outside of the parentheses, okay, at the very end. We're adding 7, okay. It is not being affected by the 2, so we can leave it at 7. All right, and that'll help us get our k at the very end. Okay, now, if we come here to complete our square, our mystery number, how do we find our mystery number? B over 2 would be what? 2, and then we have to square it. So B over 2 would be 2 squared. Our mystery number is 4. here's where you need to be careful. Are we really adding 4 to this equation? Why not, Caleb? Yes. This 4 is in the parentheses, which means it is getting multiplied to 2. So we are really adding 8 to that equation. So we need to subtract 8 to that equation. So what we have is 2 times the quantity. This factors to x plus 2, the quantity squared, and then we're left with minus 1. Has anyone noticed that this number and this number were the same in this problem as well in the problem before? That b over 2. That is a pattern you will see consistently throughout all of these completing the square problems. Okay, so if that helps, there's that information for you. Okay, so let's talk about the vertex. Eli, where's the vertex?
-2, -1.
Very good. -2, -1. Since this is x plus 2, okay, our standard form is x minus h. We have to take the opposite of what's inside. You can also think of this as a shift to the left 2. So we're going in the negative direction 2. -2, -1. I'm going to abbreviate axis of symmetry, AOX. Axis of symmetry, that's a lot of letters to write up here. Okay? Axis of symmetry. Liam, what do I want to see?
X equals -2.
Perfect. X equals -2. So, if I asked you to graph this, okay, using our transformations from chapter 1, we could move left 2, down 1. We have a vertical stretch of 2. So this is going to get skinnier. Okay, so there would be our graph. In your book, they will ask you to put it into standard form, graph it, identify the vertex and axis of symmetry, and then fourth, they will ask you to find the zeros. Flashback to chapter 1. What is our first step in finding zeros with any equation? Involves the number 0.
Set the equation equal to 0.
Set the equation equal to 0. Now, we've done all of this work with completing the square. We might as well use it, okay? So if I ask you to find zeros, we can take our equation and set it equal to 0. Okay, so let's just remember how to solve something like this. First step, add 1 to both sides. Okay. Next step, good, divide by 2. Okay, what did you say, Marissa? Okay, good. Now we have something squared equals a number. We can square root both sides. Please do not forget that when you are solving an equation and you square root both sides, we get a plus or minus answer. Okay? And we have the square root of 1/2. The square root of 1 is 1. The square root of 2 is the square root of 2. Is this something that you're allowed to leave like that? No. You cannot leave a radical in the denominator, so we would have to rationalize that number to be square root of 2 over 2. And then to solve for x, you can just add 2 to both sides. And so you would add 2, and then you can't combine 2 to an irrational number, so you can just write it as 2 plus or minus radical 2 over 2. And you're going to see it like that.
Shouldn't it be minus 2?
Oh, thank you. Yep. Copied it down wrong as I was trying to talk. Yep, so it's x plus 2, so we would have to subtract 2 to the other side. Thank you, Eli. Okay, so those would be your zeros. Right. Now, we've gone through 2 completing the square problems. I will have you do one more before we leave. But I want you to be aware of one other type of problem you're going to see in your homework tonight. Okay? You don't have to write all of the information down, but at least write down that we have a vertex at negative 411, and it passes through negative 615. We have a parabola, vertex of negative 411, and it passes through negative 615. Okay, so if I ask for the standard form of an equation, we know that in general it's going to look like this. Is there any part of that equation that we know? What's h? Okay, so we can write x plus 4 and k is 11. We at least know that. We do not know a, which means we don't know our equation in its entirety. But we do know one more piece of information. How could that be helpful? Okay, if we have this coordinate here that is on the parabola, it should satisfy the equation. So if we plug it in, we should be able to figure out what our a value is. Okay? So let's do that. Negative 6 would be our x value. And 15 would be the output, the function value, the y value, whatever you want to describe it as. Okay? Now we just have a linear equation to solve for a. So negative 6 plus 4 would be squared. So we have 15 equals 4a plus 11. If we subtract 11, we get 4 equals 4a. Well, that's nice, right? A equals 1. So we can write that the standard form of this parabola is 1 times x plus 4 squared plus 11. Okay. So, couple things. Don't feel like you need to write down this assignment because it is on your gold sheet. But this is the homework that I will be coming around and looking at tomorrow. Okay? Thursday and Friday, so tomorrow and the next day, we are going to be using our calculators to discover some information about polynomials. So I need you to bring your graphing calculators tomorrow and Friday. All right? What I'm going to do, I'm going to give sticky notes to your table. Each person gets a sticky note. When I'm done passing out these sticky notes, I will put a problem on the board that I would like you to put into standard form. And before you leave, I would like you to show me this standard form so I know that you can complete the square of a quadratic. All right? The bell rings at 9:07 and it's 9 o'clock. You should have plenty of time to do this. If you get done with your ticket out the door before 9:07, feel free to start on your homework. There you go.